Hey there, it's Professor Sills, and I wanted to bring you up to speed on what we're doing here. This is activity 1.4, and I just want to spend a few minutes kind of showing off some of the things that you need to be looking for as you worked through this activity, and just point out and maybe highlight a few of the issues. So the first thing I'm reading on page 19 of the manual is we have to open up powering tropical cyclones, and we're going to do that right now. And then we have to turn on the August sea surface temperature theme, and that's right here. Now, as we do that, we can see that the reds and the crimsons represent the warmest waters. These are temperatures in Celsius. And the purples and blues represent the coldest temperatures. Again, no great surprise, you're not going to see water below 0 degrees Celsius. That is the freezing point of water. So one of the first things that the author asks you to do is convert from Fahrenheit to Celsius. He gives you the conversion factors over along the side. You can do that, and you can check my answers separately for that. Number 2 we just discussed, and as we look at number 3, he wants you, the author is looking for you to analyze where 27 and 28 degree water is found as far north as and as far south as. And of course, feel free to zoom in. So for example, 27, 28 I can see is the bright red. And looking at this in the eastern Pacific, I can see that it might be as far north as roughly this latitude. Now, what latitude is that? If I scroll over, well, let me zoom out, because I was still on the zoom tool. And, well, that wasn't too good. We'll try this again. Every once in a while, things don't work out exactly the way you planned. Let's go back to the original extent. And then we'll zoom in again. And this time, we'll simply look at the latitude control, the latitude readout, which is right here. And you can see when I'm pointing here, it's at about 14 degrees north latitude. So you can play around with that and make sure you come up with an answer you're comfortable with for number 3, and you can do the same thing for the second blank in number 3. You're then asked to turn off the August and scroll down to themes and turn on the February and repeat the same action for February. And again, I'll let you do that. I'll let you be the one who analyzes the globe and makes the analysis that you want to make for those locations. Now, you're next asked to bring up sea surface temperature and the seasons. So we go to movies, and let's bring up the icon for movies, and we're asked to load the sea surface temperature movie. So I'll click OK to that and give it a second. It'll load the movie. I have a lot open on my computer, which might explain the slow speed at which this movie is loading. But the simple fact is that once it begins to play, as the author points out, you can use your right key, left key, your arrow keys, to move you through the movie frame by frame, which I encourage you is going to help in viewing this. Okay, so I got tired of waiting for QuickTime to open, and without having to restart my computer, I decided to launch something else called AVS Media Player. Always pays to have more than one media player on your computer. Anyway, as I simply pause and play it, I can go roughly month by month. QuickTime is a little more elegant, and I can begin to see that there are patterns here, and I want you to identify what those patterns are. That's what question 5 is really asking. It's saying, how does the shift in sea surface temperatures reflect the seasons in the northern and southern hemispheres? So you know when summer is in the north, you know when summer is in the southern hemisphere. How do these sea surface temperatures match up with that? Do they parallel it? Do they lag it? Do they lead it? Do they match at all with it? You know, those are the kind of things you would want to address in number 5 before, again, you check my answers to that. So moving on to the next phase of this, you can see the title is Searching for a Threshold Temperature. And I think most of you at this point have a pretty good idea that tropical cyclones occur at a certain time of the year, and it has something to do with a threshold in the ocean. That when the ocean exceeds a certain temperature, it will trigger, if you will, the ability for these things to act up. So here's what we're going to do. According to the instructions, we've turned off the February Sea Surface Temperatures theme, and we're going to turn on Tropical Cyclones August. That's right here. So now you see where the tropical cyclones are that form in August, and it wants us to play around with the legend editor. So to get the legend editor, it says double click the theme. First of all, we'll activate it, and then double click it. And this brings up the legend editor. This allows us to, if you will, take a look at the underlying data. And the beauty of a GIS, a Geographic Information System, is the fact that you can visualize the data. I mean, at the moment, all we have is a bunch of green dots. And we know these green dots represent tropical cyclones that formed during the month of August. Well, now what we're going to do is, if you will, massage that data and do it in a way that we can get some more information out of it. So it wants us to set the legend type to a unique value. And there are a number of ways of playing around with this, and I encourage you, you can't break it, just don't save anything after you changed it. And we'll make sure the values field is temperature Celsius. See, these are all the data columns that exist for all these various tropical cyclones. We can see the latitude and longitude they formed at, the hemisphere, the season dates, the basin that they're in, but we want temperature Celsius, and you can see here it gives us a palette of colors. Now, the palette of colors that you're getting is not particularly the most effective colors, so you can pick a color scheme that makes a little bit more sense. Fruits and vegetables, no, that's not particularly good. I would look for blue to red, because what you want is you want something which is going to run from cooler to warmer. So let's see. Equatorial rainforest doesn't do it. Warm tones, no. We were there before. Well, it's not quite doing the job that I want, so let me be stubborn here and double click, and I can actually pick a color, and I'm going to make this deep blue and close that out. That's a lighter blue, that's fine already. Let's make this one green. And we'll make this one orange. And we'll go here for a light red. And actually that'll be it. The 99.99 is simply where there is no data. And now we'll click apply. And notice what we've got here. So not only are we able to visually see what's going on, but you have counts that were in there, and I shouldn't have closed that. You have counts that you can pull the information off and just put it right into your chart on page 20. So you have quite a bit that you can work with just from this one little activity right in here. And again, if I close this, it creates an incredible visual effect for the temperature fields where we see these storms forming. So question 7 is asking you to simply put this on a graph, and if you did this correctly, you should be seeing an increasing trend up to between 27 and 28, and then above 28 you should see a decreasing trend. And that's where they're asking in number 9 what temperature do they occur most frequently, and that should be up wherever you see the maximum, which is 27 or 28 degrees. So they show that 26.7 is what they show is the cutoff needed for a tropical cyclone to form. And they're asking you simply in number 10, well, how well does your data agree with that? Do you in fact see a steep increase between 26 and 27, where at 26 degrees Celsius you don't see a lot of tropical cyclone formation, but at 27 you do? And again, if you look at the color scheme here on the map, you can see that that's also verified. So in 11, they're asking, why do you think the amount of warm water, why do you think the amount of storms declines actually above 28 degrees? And that's something for you to think about, and you can read my answer further into the solutions. And number 12, realize that there is kind of an asterisk to answering this, and you'll see how I answer it. So naturally I would leave for you to answer it for now. So that's it. We're going to wrap this video up, and now I'll leave it to you to continue on with the activity.